Okay, this is week 4 Spacey workshop for T590 Intro to NLP course. So many libraries for NLP in Python. The HF transformer is HF stands for Hugging Face. It is a very popular library. So these are the GitHub stars. This shows how popular these libraries are. So for this course, we will be mostly using NLTK and Spacey. So let's just see the pros and cons of both of those libraries. NLTK stands for Natural Language Toolkit. So the pros of NLTK are it's a Python integration. It is built for Python. So NLTK gives you the power of Python with an NLP framework, so you can write your processes with fewer lines of code. You don't have to do the NLP architecture from scratch. You already have the pre-built functions in it, so that's a pro. And then it is obviously an open source. Open source means you have lots of documentation, lots of people working on it, so you get regular updates for the library, and it is also flexible. Um, it gives access to wide variety of language frameworks and different approaches to the NLP task. When it comes to cons, it is kind of slow and clunky, uh, and when there is a lots of data, NLTK struggles to process. That's a kind of downside with NLTK. And then it is mostly used in research and academic areas. It is not preferred for the production or deployment purposes. And then when coming to Spacey, it has all the pros that I've mentioned with the NLTK. Along with that, Spacey offers neural network-based pre-trained models, which gives more accurate outputs when you wanted named entity recognitions or parts of speech. Um, it is heavily used in industry. I've used it most recently in my previous internship this summer. Um, it uses an object-oriented approach. So what it does is it has a pipeline. Spacey will have a pipeline, and it kind of performs all the components in the pipeline and has everything ready for you to access. It is not the case with the NLTK. NLTK is just string based. It just does what you asked it to do. So Spacey does Spacey or processes all the components it has in its pipeline, and it is just ready and good to go. You can just access those components through the attributes and methods the object offers. And then with the latest update to the version 3, it is all it the Spacey also added the transformers. Transformers are kind of revolutionized the NLP domain recently with the uh, what do you call it, the attention modules and stuff like that. You can look it up online. And then the cons, there's really hard to find cons in Spacey, but then uh, it majorly supports English, Spanish, and German. Beyond that, it doesn't offer much of support for the other languages. And then sometimes you just need to have a good hardware to run Spacey models, because it uses neural network based pre-trained models. So you just have to have, sometimes when the data is huge, you can see the difference, that having a good hardware would really speeds up things. And then sentence parsing is slow when compared to NLTK. That is another downside with the Spacey. Um, to begin with, to install, you can use these commands to install Spacey. Or if you're stuck or you want troubleshooting, you can always visit spacey.io website. And then so so initially, Spacey, as I said, Spacey is an object containing processing pipeline. So we usually assign that object to a variable called NLP. That is a common practice. For example, to create an English language object, you will just have to import the English library English module from spaCy.lang.en. So doing this one creates an object. Now NLP is an object now. This NLP object contains some components which we'll go through later in this session. So then the object is now created, and then we given a document. So it could be a single sentence, a single word, or like or a document, to say, or a text document. It could be anything. You pass in the text input in this object, and then it creates a document object to access what's in the document object. The first basic thing is to use dot text attribute. So these dot whatever follows the dot are called the attributes. So when you loop through what the loop does here is it takes in the sentence. The doc has the sentence, and to access each and every token, you have to iterate through the document. So we are using a for loop to iterate through that document. And then so let's say token is the iterator. For the first iteration of the document, the token has hello assigned to it. And then to access that text, you have to give an attribute called dot text to it. So that's how when it just runs through all the through the loop, you get all the tokens of the given sentence. And then to access individual tokens, you can just pass the index of the token. For example, in Python, index starts from 0. So the first document would be hello, for which the if you hit 0, then it okay. Yeah. So 0 is the starting index. So if you give 0 as the first index and you wanted text of what the text in the zeroth index is, then you get hello, which is the zeroth index. And then if you want the second token of the document, then you just pass respective index. And there are also span. Span just means the starting and ending of a text. For example, if you want the first two tokens of a document, then you'll give this :2, which is just slicing. It is called slicing in Python. So it just gives the first two tokens of the document. So that is a span. Span is nothing but it has an end. It has a start and end of an end token index. It is a span. And coming to lexical attributes, so again, as I said, all the methods that followed by a dot are called attributes. So token dot I gives the index of the token, and then token dot text gives the text of the token, and is alpha is just gives true or false, whether it's an alphabet or not. So if you see the hello world example, hello and world are alphabets, so it gives true for those things. But then the exclamation mark is not an alphabet, so it gives false as an output. And then the is punct is whether the token is a punctuation or not. So it's just the opposite of is alpha. You get true for the exclamation and false for the other tokens. And like num is like whether it has any numbers, whether the token is a number or not. So since we don't have any number in the string, it returns the false for each and every token. And then spaCy also offers a wide range of linguistic features. To begin with, let's start with parts of speech and dependencies. So we just import spaCy. I imported pandas just to display in a tabular format. It is not necessary. So first import spacey, and then so this is something called pre-trained model ncore web underscore SM, which means it is a small language model of English. EN stands for English here. If you want German, you have for German, I think it is GR. So for English, it is EN underscore core underscore web underscore SM. So it has like three models. SM stands for small, MD stands for medium, LG stands for large model. So for example, for this demo session, let's use the small English language model. So we load the model and create an NLP object, and then we create a document by passing some example string in here, and then
So,
yeah.
Hari, the small medium is basically for the document size, or?
So okay, basically those are the number of parameters of the neural network. Small has like, and let's check. So small, medium, and large are basically the number of parameters the architecture or the neural network has. I cannot find, but then you can see the size of the model. It's 12 MB for the small size, and it is 40 MB for the medium model, and then the large model is 560 MB. So the size is because of the number of parameters the model has.
Okay.
So the more parameters you have, the more accurate your outputs would be. And then again, so we have created the doc object, and we have to extract different attributes for the parts of speech. I have organized them into text, lemma, which means lemmatization. Then POS stands for parts of speech. Tag is for a tag for this POS, and then dependency, shape. Shape is nothing but the length of the token, and alpha means same is alpha is for whether the token is alphabet or not, and then is stop is the given token stop word is one of the stop words or not. So these are the attributes you can you get to use when you use Spacey, because Spacey creates an entire object and it is ready. It gives you everything. You just have to call the attribute and you can get the specific uh, uh, attribute or parameter you want out of the document. And you can also visualize those parts of speech and dependencies. So this is a sentence, and you have the POS underneath, and then these are the dependencies. How looking is related to Apple. So you get the relations through this visualization. Then moving on to named entity recognition. And again, I'm reusing the doc we have created and here. So I'm just reusing that doc. And again, for named entity recognition, it the small English model predicts it basically predicts the different types of entities present in the inputted text or string. So to extract entities, the attribute we use is dot label underscore. This is the attribute we use to get the entities in a string. So again, it is again a loop. You have to loop through each and every token in the document. So when you do when you create a document, I'll just show you this spoiler. So when you just create an NLP object, the first thing it does is tokenize the sentences. That is the first thing it does. So that is why you have to loop through each and every token of the document to get the to get different attributes of those tokens. So I'm looping again through each and every token of the document and storing them in a data frame just to organize, just so it looks good. So again, so first token is Apple. The starting index is 0, ending index is 5. and the entity it recognizes as an organization, probably because Apple is a company, but then it also takes into account the context in which the Apple is being used. So they're talking about buying a UK startup, something related to organization. So it predicted Apple as an organization. If and then UK as a GP. So if you don't understand anything in Spacey, just type spacey.explain and the particular keyword you did not understand, and just run the cell, and you would see what GP means. GP is basically geopolitical entities, nothing but countries, cities, state names, and then 1 billion. It has recognized it as a money, and Apple as an organization. Um, this is about the named entity recognition using Spacey. And then moving on to rule-based matching, um, we basically use regex to match the strings, and but then this Spacey has developed something. So it uses, as I said, uses neural network based pre-trained models. So it uses those pre-trained models to match the strings. So to start with, again, just you have to load a model. Here we are loading the small English model, and then matcher is an object. This is under the hood. It creates a word vectors. So NLP.vocab is a shared vocabulary. So this small English model has some word vectors pre-trained in it. So it uses that vocabulary to find the similar matching words. So you create a matcher object, and then you give a pattern. So the way you give patterns is create a list, and then each token, each pattern for the token should be in a dictionary. So this is a one pattern for the first token. This is the pattern for the another token. This is pattern for the another token. So so when you create a document object, um, it looks for 3 words at a time, and looks for the pattern which matches this three attributes. So once you create a pattern, you have to add that pattern to a matcher object. So this is how you add a pattern to the matcher object. This hello world is just the pattern name. You can just give anything you want, and then you have to place that inside a list and give it as a pattern. You can either create a double list here, take this off, or so pattern should be in a list inside a list. And then after adding to the matcher, so NLP now has a matcher in its pipeline. So you just pass on a string, and then you create an object, and then you again loop over each and every token match. So the matches ID, start and end tokens. So to use the start and end tokens, we use span concept here. Span is nothing but, as I told, slicing of a string. So you take the doc object, you give the start and end, and then it gives the span of the match token. And then if you can see here, the match ID, we're printing the match ID, string ID, and the starting index of the match. So we were matching the hello. Espunct colon true means here you have to match the a token with a span with a punctuation, and lower here means the lowercase. If you give upper, it is an uppercase. So basically the pattern here is match hello world span with a punctuation in between. So that is the reason it only yeah. So that is the reason it only matches this hello world. It doesn't matches this hello world, because you gave it the pattern says that you have to have a punctuation in it. So it only matches this hello world and ignores this one. If the other you can do another thing if you want to match, if you want to match a punctuation. No You can have like, you can give an option in the pattern. It doesn't matter if you want a punctuation or not. You can just add another pattern inside the patterns list. Just take off the is function equal true, or you can just say is function equal to false, give another pattern in the list. So for this time it doesn't matter if there is a punctuation or not. It just prints out both the hello worlds for you. And then next, the lexical attributes. Same, these are the attributes. Each digit stands for if there is a digit in the given token or not, followed by a FIFA, lowercase FIFA, lowercase world, lowercase cup, followed by a punctuation. So again, given a sentence, add that pattern to the matcher, create a match object, and then just loop over all the match tokens, and it prints out the matched span. You just store the match span. If there is if there is a match, then it prints out the string. If there is nothing, that it just prints none. Again, there are so many attributes you can give. Lemmatized followed by a parts of speech of noun. So here the sentence is I love dogs, but now I love cats more. So you wanted a you so yeah, I've given a pattern like I need a span. I need spans which has love followed by a noun object. So I add that to the pattern, or that pattern to the matcher, and then create a match object, and then loop over all the match tokens, and then it prints out love dogs and then love cats, because that is the pattern I've given. Then using operators and quantifiers. So we have quantifiers and operators, different quantifier and operators. Yeah, so these are the operators. This exclamation mark indicates not to match that particular pattern. Question mark suggests that uh, either match 0 times or 1 time, not more than that. Plus stands for you match the particular pattern once or more than one. And this asterisk means that match the following given pattern 0 or more times. And this gives you can just mention the number of times you want the match you want to match the pattern. So you have different operators in it. You can use that as well in the pattern. So here I used question mark, which means match 0 or 1 item. Again, create a doc object and then add to the matcher object, loop through the tokens. You'll get the matched spans. And the other thing with the Spacie is to optimize memory. It uses hash values instead of words. As I've said before, it uses a common vocabulary. This small English model uses smaller shade vocabulary, which we use shade vocabulary. It has a fixed vocabulary. The small English model has a fixed vocabulary. So based on that vocabulary, the matching happens. So instead of storing the string as it is, it uses a hash value just to reduce the memory. So for example, if you want to see the what the hash value for the coffee, the word coffee is, so this is the hash value for the word coffee, and you can just map from hash value to the word as well. Just give nlp.vocab.string of the hash value, you'll get the word associated with that hash value. Yeah.
So Hari, was that what the match ID was when you were doing the matching?
This
Also
one,
the hash value. Yeah, well, you printed the match ID above, I think, in your first match. Yeah, right there. Is that also the similar theory in the using space?
Let's see. I don't think it is the same thing.
Because I was wondering what the match ID was.
Yes, it is.
Okay,
Yes, it's the same
interesting.
thing.
Okay,
Yeah.
cool. Yeah, thank you.
Thank you. Good question. All right. And then moving on to the pipeline, the NLP has, as I said, whenever you create an object, these are the you just have these parameters by default. So you can just check after creating an NLP object, you can just check what are the processes being involved in the pipeline. So it has it the first thing it does is it just tokenizes first thing, and then it based on the input we give it either tags, parses, attribute ruler, lemmatizes, and NER. So this it doesn't affect the speed of execution when you do the small projects. But then when I was doing my internship this summer, I had an issue with the processing speed. So I had to take out the unnecessary processes just to reduce the execution speed. So to just to just have what the required processes, what you can do is when you load the model, you can either exclude the unnecessary processes or disable them temporarily. So by that way you can save some execution or the computation cost. You can save some computation cost by that. Just a small tip: if you ever encounter that the processing is taking too long, you can just disable the unnecessary processes this way. And then the word vectors and semantic similarity. For this one, I've downloaded the Medium model. I can show you the difference between what difference it makes when you use a medium model and a small model. So when I'm comparing two documents here, I got a similarity score of 0.8, which means like 86% similar. But then when I use a small language model, so the similarity score decreased to 0.7. Let's try the same thing when you compare two tokens. So the similarity decreased to like 17% from 68%. So that is a difference between using a small model, medium, and large model. The larger the model, the more parameters it has. So it has a better prediction abilities. And that is with that. And the word vectors it has. So the word vector is a context representation of a given word. So if for example the word banana, so these models are already trained on some text, and it develops some word vectors based on how based on the context of the banana. For example, let's say this value is calculated based on how closely banana and that particular word is being used. If the higher the value, if the value is higher, that means banana and some other word is being used very frequently. So basically these are like TF-IDFs. Using TF-IDF you calculate this word vectors. The dimension of this word vector is 300. So which means these scores are calculated with corresponding to 300 words which are frequently used with the banana. Top 300 words which are frequently used alongside the banana. So whenever these libraries get updated, these word vectors also get updated. Because they get trained with new data every time, so they just keep changing every time.